Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the Program Manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat, but before we begin, I'd like to quickly review two items, our Code of Conduct and Event Guidelines. First, please take a moment to review our Code of Conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. The session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link in the chat for our channel. And if you've not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to access and interact in the chat. You can set that up now. And if you're unable to use the chat but have questions, feel free to reach out to us through social media or on our website. Which brings us to today's session. Today is the second session of the Level Up with Azure Integration Services series. I want to bring in our speaker for today, Fernando. How are you?
Hello, everyone. Doing great. How are you doing, Alexia?
Very good. Thanks again for tuning in for this series. And yeah, take it away.
Well, thank you. Well, hello, everyone. My name is Fernando Rocha. I live in beautiful British Columbia, Canada, in Vancouver. And as Alexia mentioned, right, this is the second session of a four-part series that we're doing on Azure Integration Services. We're going to be talking today about exploring enterprise messaging with Azure Service Bus. We're going to go through a lot of different things here. We're going to understand first what a message broker is, right? Why Azure Service Bus is a message broker, an enterprise level message broker. We're going to go through an overview of the service itself, the architectural patterns that you can use if you choose to use the service in your own environment. We're going to talk about some advanced features that that Service Bus has. If you know a little bit about message brokers, you know that there are a lot of them in the market. Even Azure has many different versions of message brokers or event-driven solutions that help you decouple systems. So when to use Service Bus is a very common topic that comes up, right? We have some good documentation to help you choose that. We're going to talk about that a little bit. And we're going to talk about some advanced features that Azure Service Bus has that helps you make the decision when to use it or not. And then we're going to tackle something that's extremely important, which is the security side of Azure Service Bus, right? And that helps it become an enterprise-grade solution. Finally, we're going to go through a demo, very simple demo that's on GitHub. If you want to go there and do it yourself, feel free to do so. It's a very simple demo. We're just going to be creating a queue, sending some messages to the queue in two different ways, and reading from that queue itself. I'm going to be showing you how to do this as a developer using Visual Studio Code, but also from a debug and monitoring perspective by using the Azure portal to see your data flowing in and how it looks like. A little bit about myself. Again, I'm in British Columbia. I'm currently a senior technology specialist at Microsoft. I have almost 20 years of experience in IT, and the last 10 of them I have spent working with cloud components, with multiple cloud providers, but mainly helping customers and teams that I worked with modernize their applications within the cloud providers that they choose to use, right? Using cloud components. I have experience in a myriad of different industries, and currently what I do, I help customers again with application modernization and also generative AI, which is the thing that everybody's really interested in right now. Again, this is the second part of a second session of a four-part series that we're doing on Azure Integration Services, because Azure Service Bus is part of the Azure Integration Services umbrella that contains a lot of different services. Logic Apps is one that we have discussed last week. All right, if you haven't seen the session's live on YouTube already. We've built a code generator using Logic Apps. OpenAI, right, ChatGPT and DALL-E to create an image for our quote. It was pretty cool. If you want to check that out, it's also on the same GitHub repo that I'm going to share with you today. You also have serverless compute with functions. Functions are used for a lot of things, but they're also heavily used on integration services. Oh, sorry. You have ETL pipelines that you can do with Azure Data Factory. Okay, we're not going to cover it in this session, but there are a lot of cool material out there for you to look at. What we're talking about today is enterprise messaging with Service Bus, right? We're going to cover that today. In a couple of weeks, we're going to be talking about Azure Event Grid, another option for event-driven solutions to decouple systems from each other. And lastly, we're going to talk about Azure API Management. We're actually going to talk about API Management before we talk Event Grid, but Azure API Management is one of my favorite services, right? If you are working in an organization that has a lot of APIs, Azure API Management is something that is a given to you because it helps you from a lot of perspective, right? So if you're interested in that, do not miss the following sessions. And September 5th, we're going to be talking about API Management, and September 12th, we're going to be talking about building reactive applications with Azure Event Grid. Okay, now let's start. Let's start by asking ourselves, what is a message broker, right? Why do we use message brokers? So message brokers, the dictionary definition, right? Not really dictionary, but if you search for it, that's basically what you're going to find, right? It's an intermediary layer that helps decouple sender and receiver applications. And remember this, right? Decoupling, allowing them to communicate asynchronously, another key word when we're talking about message brokers, without direct knowledge of each other. So basically, I'm allowing two systems to communicate with each other asynchronously without really knowing about their behavior, right? Making them extremely decoupled and independent. And why do we need something like this, right? Why do we need a service like this, right? Why these services usually exist, why they were created. So we need to identify the problems, right, first, of solutions that we have on the market, solutions that we have created. So let's think about this particular problem that we have here. Right now, you have a producer application. It is generating some data. I don't know what data it is. I don't care at this point. But it needs to send that data to a consumer. The consumer is going to pick up that data, process that data, save on the database, send it to somewhere else. It doesn't really matter. That's a very common pattern that we see, right? A synchronous communication between two systems, maybe through APIs, right? What are the problems that you may see in situations like this, right? That you're going to need to mitigate one way or another. One main problem that you see here is if the consumer is offline for any particular reason, you're not able to send that message to it. Okay, the producer is going to try to send the message to it, and it's going to fail because the consumer is offline. So a lot of things can happen at this point. The producer will need to understand that the consumer is offline, and is going to need to manage that process itself, like resend that message, implement a retry logic in the future, for example, when the consumer is back online. But overall, if it doesn't do anything like that, that message at that time is lost forever. Okay, you're not going to be able to maintain it. You're not going to be able to process it. You lost it, right? And if you can't lose it, you may have a big problem. What are the problems associated to this, right? What are the main issues that we see that make us want to create a better process, right? Or at least make sure that we're not coupling these applications together so deeply. So first problem that we see, again, is tight coupling, right? So you have a direct integration between components that leads to tight coupling, where if you need to change one particular component, you need to have corresponding changes in every single one of the others, right? This will make your system much less flexible because all of the components heavily depend on each other. You have problems with reliability and durability. As I mentioned before, without a particular messaging service, you can't ensure that your message is going to be reliably delivered, right? Properly delivered. It can be a little challenging to do that. If a component, as I mentioned before, is unavailable, messages can be lost or not properly processed. You can have and will have scalability issues, because as the application grows, handling this increased message traffic and load can become difficult. So without proper mechanisms to handle scalability, components will struggle, right? to keep up with the communication demands that the producers are going to require. So if you have a tightly coupled solution, it's very hard to make sure that it scales properly. There's one thing that it may be a deal breaker for you, but if you can have an asynchronous solution, a message broker is a very good solution for you, because without an asynchronous messaging system, components will need to wait, right, for synchronous responses from other components. There are other ways to handle that, but usually that's how it happens. And you can have a lot of performance bottlenecks in this use case, right? Sorry. And when you have bottlenecks, you slow down the performance of your system overall. You can have a lot of ordering concerns, right? If you need a solution that maintains message ordering, if you're not using a message broker or anything in between that manages that ordering for you, it can become a complex thing to do. Error handling and retry logics are harder to create and maintain, because you're going to need to do that on your consumer side. You're going to need to do that on your producer side. You're going to need to manage them separately, but uniquely in between, right? Because we're talking about the same message. So they both need to do that. It is easier to do that when you have a single component that's responsible for holding your messages. You have, again, complex point-to-point integrations, because you have direct point-to-point integrations when you have a producer-consumer pattern that is not handled asynchronously. If you have a lot of different producers and a lot of different consumers, it becomes very hard to manage all of that. And again, you have limited cross-component communication, right? Components may need to expose APIs, endpoints for other components to communicate with. That can lead to security concerns. You may need to expose different things to different APIs. From a monitoring and visibility perspective, I know we have a lot of problems here, but I really wanted to list a lot of them, and there are more, right? Those are like the main ones that we usually see, but bear with me, we're almost done with it. From a monitoring and visibility standpoint, without a centralized messaging system, monitoring and tracking the flow of message across the systems becomes difficult, right? It's hard to troubleshoot. And lastly, you have very complex event handling, right? So in event-driven architectures, managing events and their propagation becomes intricate, right? Complex, without a very dedicated message mechanism. So this can result in very inefficient event handling and a lot of missed events. We have a question here from Samdeep. What is the difference between Azure Service Bus and Kafka, right? It's going to be a little bit more clear when we talk about the advanced features. But as far as I'm concerned, I'm not a Kafka expert, right? But Kafka is more, it can be used as a message broker, as I understand correctly, but it's most commonly used as a streaming system, right? So you have heavy load, a lot of events coming, right? Millions of events in a short period of time. Kafka would be better served. In that particular case. Service bus is more for like system to system communication, right? Even though you can have multiple producers and multiple consumers, we're actually talking about system to system communication with not the same scalability that Kafka or Azure Event Hubs have, right? Hopefully this answers your question. Now, with all of the problems that I've listed here, how can Azure Service Bus help us, right? What is Azure Service Bus? Azure Service Bus is a fully managed enterprise message broker, all right? Meaning that it has all of those amazing capabilities that a good cloud service should have, with scalability, operational ability, security, cost, all of those things that make it a well-architected solution for you to use. It's scalable, secure, and globally available. It has compliance with multiple standards and protocols, and I'm not talking only about the from a security perspective. I'm talking about protocols like AMQP 1.0, JMS 2.0. If you're already using these protocols, you can bring them to Azure Service Bus, and you can seamlessly migrate your solution to Azure Service Bus. It is very developer friendly, meaning that you have client libraries for .NET, Java, JavaScript, Python, Go, and you have a lot of development tools available. like some of the ones that I'm going to show you here that help you with monitoring and troubleshooting your Azure Event Bus instance and namespace. And you have multiple integration capabilities, right? If we're talking about integration with other Azure services like Event Grids, Logic Apps, Functions, Power Platform, Dynamics 365, Stream Analytics, multiple other services that you have available for you there to use. We have another question here for Vishnu, how it differs from Azure Event Hub. So mainly the same answer that I gave to Sandeep about Kafka, right? Azure Event Hub is more for like streaming events at large scale. There's a very good documentation. I will share that at the end because I'm not going to be able to find it quickly. But we have a very good document that I'm going to share at the end that compares messaging services and platforms and when to choose every single one of them, right? It compares Azure Service Bus with storage queues, with Azure Event Grid, and also Azure Event Hubs, okay? So it's going to help a lot with that decision. Harry has a comment here. Not only a question, service bus architectures are generally queue-based, where Kafka is stream-based, exactly. Streams are held until deleted timeout and be accessed in random order, exactly. Queues are usually first in, first out. That's a common practice, yes, and deleted after delivery. Yes, those are some of the advanced features that we're going to be talking about. Thank you so much, Harry, for adding this. So when to choose Azure Service Bus, right? That will answer some of your questions here that you have when to choose one service over the other. So first of all, take a look at the Azure Event Grid session that I'm going to do. I believe it's September 22nd. You can correct me if I'm wrong, Alexia, but we're going to be talking about another service that helps you with decoupling systems from each other in more like an event-driven way. So it may help you understand a little bit more when to use different services. But again, you can choose Azure Service Bus as your message broker, as your messaging solution, queuing solution, when a synchronous process that requires polling is accepted in your solution. For example, if your consumer is able to poll for messages that are coming that it needs to process asynchronously, Azure Service Bus is a good service for you. If you need reliable state transition management for business process, if you need something that can handle the processing of a message from start to finish, making sure that everything is working or nothing is working, right? Azure Service Bus is a good option for you. Messages cannot be lost, duplicated, or need to be consumed in a particular order, right? Like Harry mentioned, like in the first in, first out scenario. Or with a sequence number associated to them, right? Even if they come in different times, Azure Service Bus is also a good option for you. And again, if you need something that has consistency as key and a high value enterprise messaging platform that, again, grabs all of those cool things that cloud platforms have for you out of the box, Azure Service Bus is a very good option for you. Now, let's talk about some of the architectural patterns that we have. Before that, Vishnu has a question. What will be equivalent service available in the market for on-prem scenario, right? So Service Bus is one option for you for on-premises scenario if you choose to do so. You also have many different solutions in the market, right? I don't want to name some of them here and not name others because I don't want to play favoritism, but any search for enterprise queuing message or any type of enterprise service bus, it's going to come up with multiple different services for you there, right? That use the AMQP protocol, right? I will search for AMQP enabled messaging brokers, for example. You will get a lot of options there. Now, what are some of the architectural patterns that you can see or that you can use or that you can identify that you need that Service Bus can cover for you? Right? First one's a pretty common scenario, right? We call it broker transferred with queues, right? There are different names to it. Some people can call it load leveling, for example, or offline and batch scenarios. It also works. But this is the scenario that we had before, right? Point-to-point communication between two systems in a synchronous way. When you add Azure Service Bus and a queue in between, it helps you with a process called load leveling, right? Where the queue is going to act as an inbox for requests to your application. So your consumer application can process all of those requests at its own pace, without being overloaded. So if you have more messages here that you can consume at the same time, you can have your consumer application process it whenever it can, right? So it doesn't overload it. The instances of the consumer application can be created or destroyed also to mimic, right, increased or decrease increase or decrease in the data within your messages that you see on Service Bus, right? We're also going to talk about that better. But remember, when we talk about cloud solutions, we're talking about scalability, right? Scale up and scale down as it needs to do. So it facilitates the process of scaling your consumers if needed as well. You cannot use it. You can also use it as an offline mechanism to hold your messages. Again, if your consumer is offline at that point, Azure Service Bus in a queue is going to hold all of those messages for you. And when your consumer is back online, it's going to be ready to process it. Okay. You can also process all of the messages as batch messages, right? To get multiple messages at the same time and process them properly if you choose to do so. Another common pattern that we use is called competing consumer. And competing consumer is also known as load balancing. You can call it load balancing. And that is when multiple receivers compete for messages on the same queue or subscription, right? We're going to talk about subscriptions in the next slide, but in the following slides. But if you choose to use something that's some service like Azure Service Bus, you will have automatic load balancing of work when you have multiple consumers volunteering to process the messages that you have. Okay, and a good way to understand if you're going to need more consumers or not is by observing the queue length, right? If you understand how many messages you can process per second, for example, you can determine how many messages you have on the queue and determine if one consumer is good enough. If not, you add 2, 3, 4, and then you can decrease if needed as well. So you can do a lot of cool load balancing patterns with Azure Service Bus in the middle there. There's also a pattern called fan-in, right? We call it concentrator as well. And a concentrator is when you have a lot of producers sending different types of information or the same information to a queue. And you have consumers or multiple consumers consuming from that queue, right? And he understands the type of message that he has, aggregates that message, and sends it somewhere else. So, for example, if you have different data sources, right? And you have a producer for every single one of those data sources generating data for you, right? And grabbing data from the database and sending for further processing. If you have 3 different types of data sources here and you have 3 different types of producers sending 3 different types of messages, you can have a consumer pick up those messages from a particular queue, understand the different types of messages that he has, aggregate those messages into one single payload, and send it further for further processing, right? So you can do what we call concentrator pattern, or you can do multi-stage aggregation or roll-up if you choose to do so, if you have that pattern, right? Service Bus is very good for that as well. You have the process of fanning out with topics, right? And topics are a very important keyword to use when we're handling Service Bus. So topics will provide a publish-subscribe mechanism for you to use within your architecture, where producers are going to send messages, or publishers in this case, right, are going to send messages to a particular topic. And subscribers or consumers are going to receive messages from that particular topic, but filtering by subscriptions. And they can filter by specific criteria, right? Message contains a particular attribute of some type, So different components can selectively receive relevant messages and not all of the messages that are going to a topic. And that's a very important pattern because you can have multiple producers sending data to Azure Service Bus, and the only thing that the sender needs to worry about is a topic. It doesn't really need to worry about where is that particular queue where the message is going to be delivered at, right? It doesn't work like this. The producer is going to send a message to a particular topic, and it's up to the consumer to read from that topic, right, by subscribing to a particular queue using some type of filtering mechanism. So if you have producer of type A, B, and C sending messages, it's up to the consumer to filter for that specific message and process it as it should, right? So maybe consumer A is not meant to consume messages of type C, so it's not going to do anything like that. All right. I think there's a great conversation going on there. Harry's helping a lot. Thank you so much, Harry, for answering some of the questions there. It's very helpful. And again, a good thing to understand here is producers only know about topics, right? And receivers only know about subscriptions in this particular case, because we're talking about a completely decoupled solution, right? So this is handled the easiest way possible for producers and the easiest way possible for consumers. So good question here. Does Azure Service Bus have a throttling feature where there can constrain the number of messages that are being received, processed at once? Yes. Yes. Most of cloud services have that, right? And it's usually associated to a quota. So that quota can be associated to the size of the message that you're using or the number of requests that you're sending per minute. So throttling is there. Good thing about throttling is if you're using the SDKs that are provided to you, some SDKs are already handling those throttling retries and exponential backoffs that are needed to do those retries, right, when you get a throttling exception from the service itself. So you can leverage that. But yes, it's always good to take a look at the quotas to see not only if you're sending more messages or more requests than it is able to hold, right, at a particular time. And most importantly, if you need to change the tiers or build your service bus in a particular tier, that will help you mitigate those throttling issues. Okay. Now let's talk about some of the advanced features that Azure Service Bus has that will help you decide if it's a good solution or not for you. I just realized that I don't actually need my headset here for this session, so I'm going to take it off. So what are some of the advanced features that you see on Azure Service Bus? And there are many of them. So first one, very common thing that you see on service buses throughout the market, right? Messaging brokers, which are dead letter queues, right? Dead letter queues are going to allow for safely discarding messages that cannot be processed by the consumer for some reason, or maybe require some sort of troubleshooting because they have a different type of structure, payload that you're not used to, or that the consumer cannot process, right? Because it's throwing an exception, or it's going to fail, or it's not matching a particular pattern. You can send that to a dead letter queue. So the way that works is the consumer is going to pick up that message from the queue. It's going to understand that that message cannot be processed, and it's going to send that message to a dead letter queue, right? So that message is not available anymore at the queue level, in the queue itself, but every single queue in subscription, they have a dead letter queue associated to them that is meant for a particular process like this, all right? So dead letter queues can be used for producers to take a look and see if the message needs to be reprocessed. A very good pattern to have is to have monitoring associated to your dead letter queue. So when you have a message there, you can run a process that can be either manual by a developer or an automatic process to understand why that message is in the dead letter queue and how to reprocess it. Because if you cannot lose messages, it means that you're probably going to need to take a look at that message later, right? So that's a good way to understand when something needs to be reprocessed or not based on a failure. Another very interesting, useful feature that we have is the duplication, right? The duplication is going to prevent the duplication of messages that are usually caused by application issues or network failures. So let's say your producer has sent message with message ID 1 to the queue, but he hasn't received an acknowledgement back because it has failed for some reason, right? Network issues, application issues, something has happened, right? So producer thinks that message 1 has not been processed. So it sends message 1 again. In that particular time, if you have the duplication enabled in your queue, Service Bus is going to automatically discard that duplicated message. All right? And the consumer is only going to see 1 to process. Another one that's pretty popular is message deferral. So let's say you are a producer and you're sending a message to a message queue, right? The consumer, once it receives that message, it can choose to do a couple of things. It can process that message, or you can defer that message back to the queue, meaning that maybe the consumer is not ready to process that message at that time. Maybe it's waiting for another process from another system to complete. Maybe that message is in an order that is not ready to receive it yet. So the situation here is you're going to need to process that message at some point, but there's no problem in that message. That message does not need to be troubleshooted per se, right? So it's going to be processed in a few minutes or a few seconds or when a process is done. So you can defer that message back to the queue. It's going to have a sequence number associated to it. And then the consumer is going to be able to pick up that message again after some time by using that particular sequence number. Okay, that's another very common and used feature when we're handling messages using Azure Service Bus. So these are some of the features that Azure Service Bus has that other services like Event Hub may not have, or Azure Event Grid may not have, or storage queues may not have, that help you make up your mind when to use it or not. I have a question here from MVO. How does the Service Bus handle DDoS attacks and other security concerns? I have a public web form that submits data to a Service Bus queue. If it gets hit with a DDoS attack, the Service Bus have protections in place. Well, it has protection in place in a way that integrates with different services. That's one of them, right? We're going to talk about that in the next slide, actually, after the also slide. So you can integrate that with virtual networks or web application firewalls that can help you prevent DDoS attacks, application gateways. But in itself, what it has is throttling mechanisms that is not going to allow for multiple requests to reach your service bus if needed, right? So it may incapacitate your service bus at some point, but it's not going to let all of those messages come in, right? So I would always recommend using it with other services like Web Application Firewall, Azure Defender, other services that you can use that can help you mitigate these issues by understanding where that malicious traffic is coming from and block it at a network security group level, or web application firewall level, or application gateway level, however you want to use it. So per se, it helps you. But to summarize, Azure Service Bus on its own helps you by using throttling, but by creating a well-architected solution with other services that help you with the security paradigm, it will completely mitigate it, and your system's going to continue to function without any issue. Now, other advanced features that are very much used by the market are scheduled delivery. You can deliver messages at a particular time for consumption if you choose to do so. You have message sessions, right? Very important pattern to use, or very important feature to use on Azure Service Bus. Mainly if your application requires messaging ordering and processing in a particular sequence, you can use message sessions for that. It will maintain the order of the messages in a particular session. You have message browsing, most commonly known as peeking, right? Peeking is going to allow you to see, enumerate all of the messages that you have on a queue or subscription without processing them. So you're just looking at them without removing them from the queue if you're processing them, right? That's the usual pattern. You have auto forwarding. If you have transformation scenarios where you need to forward messages from one queue to another, you have auto forwarding from one queue to another if needed after processing. Transaction groups, transaction processing with transaction groups, right? Where you have maybe 2 or more operations that you can add to what we call an execution scope, where a transaction must ensure that all of the operators belonging to a given group of operations are either all working well or failing jointly, right? So that guarantees that all of the transactions are acting as one unit, which we often refer as atomicity of a particular transaction, right? It's either all or nothing. You also have auto delete on idle, meaning that you can have messages that you send to the service bus with a particular time to live. If that time to live expires, the message is going to be automatically deleted for you. You have geo-disaster recovery also, right? Very common feature in service in solutions that are built on the cloud, meaning that you can have a multi-region solution where if a region goes down, your service bus is going to be replicated in another area, right? In another region. And more, right? So I have a link here for you. You can go to aka.ms/Azure Service Bus docs and see all of the advanced features that we have there and how to implement them. A couple of questions here. Does Azure Service Bus support message transformation in the broker? Yes, with actions that you can have on subscriptions, right? You can go to the link that I provided before here. Take a look at the link, write it down. If you can share that link, Alexa, that would be great with them, because it's going to show you how to do that with subscription actions. You can do that. Does message browsing feature allow me to is it allow me to execute SQL style queries on the queue contents? Yes. You can do that. Oh, only for picking? I would need to double check that, honestly. I would assume yes, but I would need to double check that, honestly. But the messaging browsing feature, if you can execute SQL-like queries in subscriptions, right? So I don't see why this wouldn't help work with picking as well. Is auto forwarding applicable with the same service bus only to any other service that we can do that? You have integration with other Azure services, right? And I'm not sure if you need to have it in the same namespace, right? I would assume no, but I will need to double check that for you, unfortunately. Okay, need to double check that for you. I don't have the answer for you in this particular case, if it's only on the same namespace or it can be multiple namespaces. I would assume so, but that's something that I would need to double check for you. So if you can contact me after, I can give you that answer. And once I find the answer, I'm going to put on the comments of the session at the end. Schema validation of messages using something like Apache Avro. Also a question that I don't know the answer to. Okay, I also don't know the answer to if you can do that with Apache Avro, because I'm not too familiar with it, to be honest. If anyone knows the answer and can help Harry, that would be great. I don't know Harry, unfortunately. I don't know. I can check that for you as well later, right? Just contact me via GitHub or LinkedIn. Now, on security, what are some of the features that Azure Service Bus brings to you from a security perspective, right? Which is the most important thing. Security should be #1 priority for all cloud systems. So we have VNet integration, we have virtual network integration with network service group support, security group support, of course. That will help you keep your service bus secure and only available for services and applications that are within that particular environment that you control. Have Azure Private Link. If you want to keep that communication between your applications, producers, and consumers and the service bus private without going through the public internet, you can use Private Link for that. You can authenticate and authorize your access to Azure Service Bus in a couple of ways. One of them is by using SaaS tokens, right? The second one, most, I believe, it should be a norm and a pattern for most systems that are production ready, is Azure AD authentication. You can also do that not only for your management plane, but for your data plane as well. You have data encryption in transit and at rest using Azure or customer managed keys. So you can use your own keys to encrypt your messages that are on Azure Service Bus as well, right? To make sure that they are encrypted. You have data leakage and loss prevention out of the box with Azure Service Bus. You can use other Azure services as well to detect sensitive data and classification and classify that data that's within Azure Service Bus. If you have PII, PCI information, intellectual property, all of that can be detected within your Service Bus instance. And you have end-to-end tracing and diagnostics, right? Azure Service Bus provides a very good monitoring. It provides very good monitoring capabilities for you to understand its metrics, right? What is being generated, what is being produced, the type of failures that you have. And not only that, from a diagnosis perspective, right? From a security perspective, that's very important because you want to log things that are going on your service bus so you can send that to Azure Defender, for example, for further processing. Okay. Now, that ends the presentation itself. We do have a GitHub repo there that I have created for you to work with. If you could share that with them, Alicia, that would be great. I want to show that to you very quickly. So we have this GitHub repo here called Reactor AIS, Azure Integration Services, where I'm going to put all of the content associated to the series that I'm doing on Azure Integration Services, where you have Azure Logic Apps that were created that we did last week. You have the demo for today. You're going to have Azure API Management and Azure Event Grid. On Azure Service Bus, we're going to be doing a couple of things, right? Mainly, we're going to be creating an Azure Service Bus namespace, a queue, adding data to it, and read the data to it, consume the data from it, right? It's all in the README file here, how to do it, the things that you need to do. We're going to be working with Azure CLI commands here. If you don't have Azure CLI, you're going to need to install it to run this, right? And I think it's best if I show you this here on Visual Studio Code. Again, first thing that we're going to do, we're going to set up our environment. And my environment here was previously created, or at least I hope I remember to create it before the session. Let me double check here. Let's hope it's here. Yes, it is here. Great. Good. Because this takes up a little bit of time. The first thing that we're going to do here in this demo that's already done, we're going to set up our environment, right? So I have a couple of variables here that I need to set up. My resource group, my namespace, which is the name of the instance of Service Bus that I'm creating, the location of my Service Bus instance. You can choose the location that's closest to you, and a queue name. In this case, I'm calling it session queue. I'm going to create a resource group. If you're not familiar to Azure, resource group is one of the ways that we use to organize resources related to a particular project, to a particular environment, to a particular workspace. We can use resource groups for that. You can think it as a logical folder that we use to hold all of our components together for a solution. In this case, I'm creating a resource group called Reactor SB Group. I'm creating a namespace within that resource group in East US called SBus Rocha F Reactor. There are a couple of things here on Service Bus that everyone has a pattern on how to create or name their services. I like to do it in a particular way where I put the initials of the service at the end. Service Bus does not allow me let me make this bigger here. I think Harry wants this to be a little zoomed in. Let me know if this is better, Harry. Right? Service Bus has a couple of rules about naming your namespace. You cannot have SB at the end, right? Which is something that bothers me a lot, to be honest, but we just need to deal with it. So I created SBus Rocha F Reactor. And then we create a queue, right? And the queue name is going to be session queue. So very simple commands from Azure CLI. That takes about 2 minutes to complete. That's already done for us. Okay. Now, what are the other things that I want to do in this case? 1 second. Now that I have set up my environment, I need to set up 2 connection strings, right? I need to set up a connection string, export my connection string, which is going to allow me to connect to my Azure Service Bus. All right, Siegfried, the purpose of Service Bus namespace, yes. I should have a slide for that, actually. So the Service Bus namespace is basically the name that you give your Service Bus instance. It's not only required, it is what Service Bus is, right? It is what's going to hold all of your topics, all of your queues, all of your subscriptions. It's going to be under a particular namespace, all right? That's going to give you the URL and the connection string that you're going to need to connect to your Service Bus. So it is required. And it is created for you, right? Without that, you cannot create your queues. So the first thing that I want to do here, I want to export my connection string so I can use it in my Python file that I'm going to be using to create messages and read messages from my Service Bus queue. So I'm going to need to do that in a couple of places. That is going to give me the ability to see the connection string that I could pick up from my portal as well, but I'm exporting here because we don't need to see it at this point. Another thing that I'm going to need to export is my queue name, right? So my Python file is able to identify what I'm working with here. And now I'm going to create 2 files, right? First, what I want to do is send information to my queue inside Azure Service Bus. First of all, we have a question here from Siegfried. Is it possible to have multiple queues sharing the same namespace? A namespace can have multiple queues, so yes. So the idea is you have a namespace with a lot of queues in, or you have a namespace with a topic and a lot of subscriptions in, right? That's the hierarchy, right? So the answer to your question is yes. Now, let's create a couple of files here. The first file that I'm going to be creating a sender to send my information to Azure Service Bus. It's on the side here. I'm not going to need it right now. I have my sender file here. First thing that I want to do, I want to install Service Bus, right? I want to install the package for Service Bus, which is Azure Service Bus. You can do that by running, if you're running Python, a pip install Azure Service Bus. I'm not going to do it myself because I have done it before, so there's no reason to it, but that's something that is needed, right? It's a prerequisite. It's on the instructions. So on the sender, what I want to do, I want to send messages to my queue in a couple of different ways. The first thing that I want to do here, I want to import OS. It's a Python application, right? I also want to import from Azure Service Bus. I want to import a couple of libraries here. I want to import Service Bus Client and Service Bus Message. Thank you so much, GitHub Copilot, for adding that to me automatically. I want to create two variables here that are going to hold my connection string and my queue name. So connection string gave a name that is not the name that I have created before. So let me fix it. So that's the name that I have exported before, right? And I'm going to have a queue name, which was also exported in a previous step. Okay, now I want to create 2 types of mechanisms here to send messages, right? The first one, I'm going to send a single message, send single message, all right? And that single message is going to be a Service Bus message with a particular string associated to it, right? In my case, I'm going to say, welcome to, I'm going to say Reactor for Azure Integration Services. Okay. Next step that I need to do, I need to pick up the sender that I'm providing here as a parameter to my send single message and use it to send all of the messages that I have created, right? You can send a single message if you want to, and if you want to send an array of messages, it's also doable, okay? You can also send an array of messages. Instead of sending an array of messages, I'm going to send messages in batch because it gives me some capabilities like being able to handle beforehand if the message is exceeding the maximum amount of bytes that a message can have. If I send it as an array, I may face that issue. If I send it in batch, since I'm sending different messages at the same time, right, I'm not going to have this problem. And if I send this as an array, even though I can treat it as different messages, it's all going to feel like it's all going to be treated as a single message in bytes. So you may have problems. So let's do it with batch messaging, right? So let's create send batch messages, right? And it already created a lot of cool things for me here. So batch message, the first thing that it does, I need is to create a batch, right? To start sending these messages. And I don't know why this while true is here, but the first thing that I want to do, I want to add a verification here with a try and catch to see if I get a particular exception. But now that I have a batch message that I have created, right, I can start adding messages to it as service bus messages like we have created before. So I'm going to create a service bus messages that says Azure Logic Apps. I'm going to create another one that says Azure Service Bus. I'm going to create another one that says Azure API Management, and the third one that's Azure Event Grid. Again, if you're running a real system here, you're probably going to send some JSON payload to this so it can be processed properly by your backend, right? But in this case, we're just sending simple strings for it to be just collected. You can have an exception here, right, that checks if the batch message has reach the maximum size. So you can remove that message or recreate it if you want and send that batch message again. But in this particular case, we're just going to print an error here in error. Simple like that. Not going to go too far. In a production environment, make sure you're doing something better. And at the end, I'm going to send all of those messages using my sender and using send messages, passing my batch message that was created. Right? What is the next step? Now I need to actually send the message, right? I need to create the process that sends the message, right? The message sender that's going to be sending this message. So the first thing that I need to create is a service bus client. And the service bus client is going to be created from a connection string, right? And the connection string is the one that I have created and exported before. And I'm saying that I want logging to be enabled in this case. Now, with my service bus client, get some lines to it here. With my service bus client, what I want to do now is create my sender. And my sender is going to be my service bus client get queue sender, right? There are a lot of things that you can do with the service bus client. In this case, we're just going to pick up the queue that we have created, right, based on the queue name. And we're going to say with that sender, I'm going to send a single message passing the sender that I have created. And I'm going to send batch messages passing the sender that I have created. And with that, I can basically say that send message is done. Okay, let's see if this is working. Or if I misspelled something. So sender by. All right, I have an error here. Batch message, okay, that's wrong. It's not that. Service bus sender object has no attribute create batch. Isn't it create batch? Service bus message, 1 second. Create message batch, sorry. That IntelliSense should help me with. Just fix the error there. Save, let's run again. All right, send message is done. So there are a couple of things I can do here at this point. If I'm a developer, I may want to go to my queue itself, right? Inside my Azure portal. I know that I have 6 messages, 6 active messages, no dead letter queue messages. no scheduled messages, and no partitioning in this case. But if I go to my queue, there are a couple of things I can see here. There's no partitioning, no duplicate detection, no sessions. I haven't created any of that when I created my queue. You could, right? But if I go to my Service Bus Explorer, and that's one of the coolest features that we have, right? You can go to your queue itself and peek for the messages that you have received. So if I peek my queue here, I'll see every single message that I have. And not only I'll see the payload that I have created, I'll see that it has a sequence number, a message ID, the time that that message reached the queue, the delivery count, how many was delivered, the state of that message, the size, and the message text that I have created, right? Apparently I've sent this one before and haven't, oh, it worked for some reason. Yeah, of course. So we sent this one twice. That's something that we could have caught somehow with deduplication, maybe, even though they don't have the same message. We're going to need to add some patterns to it. But I see all of the messages that I have created here, right? The reason why I have 2 of the single message that I've sent is because the problem that I had was caught only in the batch message. So single message was already sent at that time. Okay. We only have 4 minutes left. So instead of going line by line of what we're going to be doing here on the receiver, I'm just going to create the receiver file here, just go through the codes as one thing. But what the receiver is doing, basically the same thing in the beginning, right? I need a connection string, I need a queue name. It's creating my Service Bus client, right? But the difference is right now I'm getting a queue receiver. I'm understanding which queue I'm working with. And I'm collecting the received messages, right? With the received message API here, I'm saying that the maximum amount of messages that I want to collect are 10. And I have a maximum wait time for those messages to be received, 5 seconds, right? Let me increase this to 60. So this is going to keep the connection open for 60 seconds so I can continue to receive messages if I choose to do so. And then I'm just going to print the message and say that the message was received properly. Again, if you go to the GitHub, to the GitHub repo, you see all of that step by step. Now, if I run this, it's going to receive all of the messages that I had on my queue, right? All of the 1, 2, 3, 4, 5, 6 messages that I had on my queue. And if I go back to my queue here in my Service Bus Explorer, my queue is empty now because all of the messages were processed, right? Another cool thing for us to see here, I can run the receiver again. And the receiver is running at that point without reading any messages. But since it's open for 60 seconds, I can send some messages to it, which are going to be picked up automatically and then closed. See? So that means that I can send messages, the messages can stay there, and when I have my consumer ready, right, I can just go there and consume the messages whenever I want. All right, we're right on time. Good timing. Okay, so if you want to see this demo and the demo for the previous session and the upcoming sessions, that's the repo to go to. I believe Alexia has shared this with you already. And again, first of all, thank you so much for joining me here today. I hopefully you were able to understand what Azure Service Bus is used for. We did an overview of it, where I showed you some different architectural patterns that are used when you play with Azure Service Bus on your side, right? Why is it used for? Where some of the advanced features that differentiates it from different offerings from Azure or offerings in the market. I also talked about security and a very quick demo, right? One thing that I would advise you to do, go to that Azure documentation that I shared with you previously. You will see all of the SDK documentation there, right? For any programming language that you want to use, not all of them, but .NET, Java, JavaScript, Go, Python. Go there. There are a lot of amazing examples for every single one of the architectural patterns that we have discussed. All right? And let me know what you build. Connect with me, and I hope you enjoyed the session. And I'll see you on the following ones. Thank you so much.